All right, this is a video for geometry on trapezoids and kites, and so we'll be looking at some particular characteristics of those two particular polygons. Let's start with trapezoids first. As a reminder, a trapezoid is simply a quadrilateral that has one pair of parallel sides. So in this case, the top and the bottom are parallel of this trapezoid, and additionally, however, in this trapezoid is a special kind of trapezoid that's an isosceles trapezoid, meaning that the non-parallel sides are congruent to each other. That's what an isosceles trapezoid means. So we're going to go through looking at a few different shapes. What I want you to do is try to pause the video and see if you can discover some unique or interesting characteristics relating to either the base angles, the base angles of this trapezoid, or separately the diagonals of this trapezoid. So pause the video, see what you can figure out. Let's work with base angles first. So the base angles of the trapezoid are these two angles, and those are going to be congruent. Okay, so those two angles are congruent. I hope you can imagine our trapezoid could be flipped upside down as well, right? And these could be the base angles also. The base angles are just the angles opposite the congruent sides. So these angles would be congruent as well. It doesn't really have to be on the top or the bottom of the trapezoid, but those angles would be congruent as well. Okay. And next, let's look at the diagonals of a trapezoid. So we'll draw those guys in, or the diagonals specifically of an isosceles trapezoid. And those diagonals are going to be congruent also. Okay? So this diagonal is going to be congruent to that diagonal right there. Only true for isosceles trapezoids. Okay? So keep that in mind. Keeping with the idea of working with trapezoids still, here we don't have an isosceles trapezoid. I want you to try to think about what might be true about the mid-segment of this trapezoid. Okay, so recall the mid-segment is a line that connects the midpoints of the trapezoid. Okay, so that's the mid-segment of the trapezoid. And what might be true about that mid-segment? The mid-segment is going to be parallel to the bases. Okay, so what we can conclude is that this mid-segment would be parallel as well to the top and to the bottom base. And it's a unique, I think it's a helpful thing to be able to create a parallel line just by measuring lengths. So if you know you have a trapezoid, just pull out a ruler and find the midpoint of that side, connect them, and you have a third parallel segment. All right, let's look at finding some angles here, and let's try to find all the angles in this particular trapezoid. So it does look like we have an isosceles trapezoid that we're working with because the non-parallel sides are being labeled as congruent. So the base angles will have to be congruent. Okay, but let's find angle D and angle E as well. And so those would be congruent angles, and we can write out an algebraic statement that says 2x plus our 265s has to add up to a sum of 360 degrees. So that tells us that 2x plus 130 is 360. Let's subtract 130 from both sides. So that says 2x is 230, meaning x is a 115 degree angle. So we have two 65s and two 115s. Let's use the mid-segment as well here. Okay, so here we have a trapezoid, and we are being told that we're working with a mid-segment. And we have the top length is 4x minus 10, and the bottom length is 8, and the length of the mid-segment is x plus 2. Okay? So one thing I didn't mention above involving mid-segments is that, and I'll add it in right here, the mid-segment length is the average length of the two bases. Okay, and that makes a little bit of intuitive sense to me, right? So thinking about this mid-segment length being the average of the short base and the long base. Okay, so that would be the length. That would help us find the length of the mid-segment. So let's do a little bit of math here and solve this one. So average means we add the two values together and divide by 2. So the length of x plus 2 is equal to half the sum of the other two bases. Okay, so the length of x plus 2 is equal to half the sum of the other two bases. So let's simplify as best we can. This turns into 4x minus 2. We can distribute the half. X plus 2 equals 2x minus 1, and it looks like we're close to getting it done. Let's subtract x from both sides. 2 equals x minus 1, and add 1 to both sides, and we'll get x equals 3. So that would mean that our bottom length we know is 8, our mid-segment length is 5, and our top base is equal to 2. A little bit of work with kites next, and again, as we've been doing, I encourage you to please try to investigate, discover some results on your own. So first, let's remind ourselves about kites. Kites have 2 consecutive pairs of differently congruent sides. Okay, something like that. And let's work with diagonals first. See what you notice around diagonals. Okay, so first let's name some things. I call this the cross diagonal, and I call this the symmetry diagonal. Okay, so the symmetry diagonal connects the two vertices that are formed by the intersections of the congruent sides. And the cross diagonal connects the vertices that are formed by the intersections of the non-congruent sides. Okay, and what we can conclude here is the symmetry diagonal is a perpendicular bisector. Okay, and next let's work with angle bisectors. See if you notice anything around angle bisectors. And what we can conclude here is that the symmetry diagonal, but not the cross diagonal, bisects each vertex angle. And that, I think, is intuitive just in the way that the symmetry diagonal creates a line of symmetry through the kite. Okay, so you would expect those two angles to be congruent. All right, so let's do an example here. This will be our last example for this video. And so we have a kite, and let's label. It looks like those are the congruency pieces that we know, and we're trying to find the measures of angle 1, 2, and 3. Looks like angle 1 is going to be 90 degrees because of that rule that the diagonals are perpendicular to each other. Angle 2 we can get from working in this triangle. We can realize that 90 plus 52 plus angle 2, which let's refer to it as x, equals 180. So x is going to be 38 degrees. And angle 3, just to recall that angle 3 is going to be the same as 52 because that symmetry diagonal creates an angle bisector. So angle 3 is 52 degrees. All right, lots of things to remember around trapezoids and kites, but we did it, we got through it, and that's a good place to stop.